Hello guys, today we're doing LeetCode question 380, insert delete get random in O1 time complexity. So this is a more object-oriented programming question. The question is implement the random size set class. The random size set initializes the random size set object. Then Boolean insert integer value inserts an item or value into the set if not present. Returns true if the item was not present, false otherwise. Boolean remove integer val removes an item val from the set if present. Returns true if the item was present, false otherwise. Integer get random returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. You must implement the functions of the class such that each function works an average of O1 time complexity. So example 1, input is equal, well, we randomize a set, so there's no return value. We insert 1, literally. It doesn't exist. So we insert it and it returns true. Then we remove 2, it doesn't exist, so we can't delete it, returns false. We insert 2, it doesn't exist, so we insert, return true. We get random of nothing, so no input value, so we return 2 is the random one we return. Then we remove 2 exists, we remove it, so it returns true. Then we insert 2, we insert 2, yep, returns false. So we remove 1, sorry, that's true because 1 is in the set. Then we insert 2 is still in the set, so we return false because it exists, we can't insert it. And we get random, as 2 is the only number left, we can only get 2. So the way we're going to do this is by having a map to store the value that we insert and the index position, and an array to be able to get the randomized number, because you cannot get a randomized number from a map without going to ON by turning it into an array. And same with a set. Now JavaScript does have a set built-in method, so you could do these two in O1 very easily, but with get random you can't do that in O1. You'd have to turn it into an array, so that would be O of n time complexity. So let me show you how we would do it here. So let's say we have a map here and we have a array. So currently they're both empty. Then we insert 1. So now we put in a map. We have 1 of index 0. And then in array we have 1. Then we insert 2. So now we have 2 of index 1. In array we have 2. Then we insert 3, so we have 3 of index 2. In array we have 3. Now let's say we want to delete 2. To delete from the array we would have to traverse through the values, which would be of ON time complexity. So instead what we do is we get the value of map, which is 1, which is the index position. So we delete, we get index, which is 1 here. Index is equal to 1. So now we delete this from the map. We delete this from the map, we delete from the array the position of 1, so now it's 2. So only 1, 3 in the array. Now you can still see that the index of this is wrong now. So then we check if the index is not equal to the last position, we then change the index of the map to the index here as well. So then we set the last value as 1. And then if we want to get random, seeing as we have an array now, we can just get random from either this or this in O1 time complexity by getting the exact index position of math.random. But we wouldn't be able to do it with the map because we'd have to turn that into an array, which is O of n. So let me show you how we do this in code. Okay, so the first thing we do is we initialize the map. So this dot map is equal to new map. Then we initialize the array. So this array is equal to this. Now insert is pretty easy. We just check here. So inserts an item value into the set if not present. Returns true if it was not present, otherwise false. So if the map dot has the value already, then we return false. Otherwise we insert it. So this dot map dot set value is the value, and as the key, sorry, the value is the key, and as a value we say as the either the array dot length or the map length, it doesn't really matter because they'll both have the same length. And then we push into the array the value. And we return true to signify we've inserted it. Now the reason we do this and check if it exists is because a set can only have unique values. So if it does exist, we can't insert it. Even though JavaScript always has a built-in set method, here we're just pretty much creating it from scratch, as if it didn't exist. Now remove is a bit more complicated. Now remove integer value removes an item value from the set. If present, returns true. If item was present, false otherwise. So if the map does not have the value, then we can't delete it. So we return false. Also, this has to be this.map. Mistake. Now, if it does exist, we have to get index position of the map first. So let index the value, sorry, is equal to map.get value. Then we get the last position of the array as well. So let last is equal to this.array array.length. Oh, this.array.length -1. It has to be this as well. This, okay. Now we delete from the map, so the value. So this.map.delete value. Then we check if the value to be deleted is not equal. So if the index position, sorry, of the value to be deleted is not equal to the last array of the last position of the array, then we have to swap the values in the map. So the index positions, because we know we're deleting one that's not last, so we set a different one to the last one, if that makes sense. So if index is not equal to this.array array.length -1, then we set the position of the map. So the value, this.map.set, so the index position, the last position, the last number, which is the value we need to keep, to the index position, which is the current position of the value we're deleting. So we keep the position the same, but we delete the value so that it will stay the same. Then, we have to set the last position in the array. Sorry, not last position, the index position of the array that we're deleting. So this.array index to the last value. The reason being is we want to delete the current index position, so we want to duplicate it to the last value, which is not being deleted, and then pop the last value. This way it's in O1 time complexity. And then we just pop the last value of the array, as mentioned, O1, and return true to signify we've deleted the value. Now randomize set just gets a random value from the array, from the set. So we'll get this.array, and then we get from this.array, oh no, sorry, we have to first floor it. Reason being, index position can be from 0, and we're about to randomize it. So math.random times this.array.length. The reason we floor it is because it can be from index position 0 up until array.length, but array.length is not a value because the last position will be array.length -1. So if we floor it, it will go down 1. So now it can be anywhere from 0 to the last position. And then we return this. Return. Now let's see if that passes. Ah, yep, this.map. If this always catches me out. Oh yeah, this.array. What I do with this.array dot push, this.array dot push. Okay. Perfect. As you can see, it passes. Let's submit. As you can see, it's one of the fastest methods. All of these are in O1 because this is directly inserting into the map. Same with the array, pushing it all the way to the end, which is O1. Here as well, we check if it has it, doesn't, or 1. Otherwise, we get the index, we set it, and we replace it. We don't have to loop through the whole array. So it's again 01. And getting random is just exactly getting the index of a random number, which is 01 again. Thanks for watching.